Untitled Chapter. I'm the first mammal to wear pants.
I live with this guy. Okay, we're here at the desk of Lady Ada. It's late night, but we won't stop engineering. And I thought I'd give people an update on Circuit Playground Express, which I have gotten back to working on in the last week or so. And I know it's been a couple weeks since my last update, but we're making progress. So what I did over the last couple days is I finished that QTOUCH reverse engineering that I started on. And that's really good stuff. I finally got it working 2 nights ago. And then I'm still wrapping it up. It's not ready to be published yet just because I'm still finding bugs. But I thought I would show it off a little bit. So how about we go to, I guess we're at the compy. Actually, let's go to the overhead. That's what I meant.
Oh, you know what? I gotta add that. Shoot.
Oh, I thought we only have the macro?
Yeah, we got the macro.
I got the macro. It's super macro-y.
Yeah, I don't know which one the other one is. No.
Hold on, I can adjust this maybe. We can just show close-ups of hardware. Okay, so this is the new version of the Circuit Playground Express. And move out of the way here. So we still have that same Mega chip, but over here we used to have resistor packs that would allow us to do capacitive touch on all the pins, basically by using a spare pin and toggling it and measuring the decay over time for the through a big resistor like a 1 mega ohm resistor. And we did a couple streams about that and how that works, and that's all good. But I wanted to get rid of those resistor packs, mostly because they took up space. It wasn't even a cost thing. They're not very expensive. But I just didn't want to have those extra resistors if I could avoid it. So by using the chip's internal ability to do capacitive touch called QTOUCH, I could basically remove those resistors, save space, save money, and I wouldn't have like these extra pull-ups, and I wouldn't lose that pin to do the manual capacitive touch. The trade-off, however, is that QTOUCH is not open source. It's a closed library that Atmel, now Microchip, releases, and you have to link it in directly, and that actually isn't something we can do because we're going to be using Circuit Playground with MicroPython, and we don't have enough space to link in this like 50K library, and we're also using it with MakeCode, which can't do dynamic linking to libraries. All the code has to be like raw C code because they use their own linker. And that was kind of the deal killer for it. I was like, well, if I can't link it within MakeCode or CircuitPython, it's kind of sad. Also, I didn't like that there's not a lot of control. Like, it did a lot for you, but it almost did a little too much for you. So like a couple months ago, I started the reverse engineering process. I showed how to disassemble the library file, and then I started decompiling library file. Maybe I'll do eventually a longer write-up on how I did that. But last we checked, I had the resistor map, and I also had started reverse engineering some sections of code. Well, I finally pulled that all together, and I made a library called FreeTouch. And so far I've gotten working on port A. So can you go to the computer, and then you can go grab a beer or something. Go do a man thing. This is my code so far. This is the FreeTouch, just showing it in Arduino. So now what you can do is you can define each object. So normally with QTOUCH you have it's kind of like a very, ball of mud, like you kind of do everything at once. What I like is now that I have full control, I can instantiate individual objects, one per capacitive touch sensor. You can set the oversampling rate, the series resistance, if you want to do frequency hopping. And then you begin, and that actually does like the muxing for you. And right now it only works on port A, the port A pins. So it only works on half the pins on Circuit Playground because I kind of didn't do the muxing right for port B. I have to fix that. It really hard crashes if you mess up the pin muxing. But then you can measure from the sensor individually. Instead of measuring all the sensors at once, you just measure each sensor as you want it, and then you can always tear it down and bring it back up. So I thought I would just show running this code on Circuit Playground, and I will clip onto
You want
the
to do overhead?
pins. Yeah, let's go to the overhead, and I'll clip on. So I'm going to clip on to pads 8 and 9, and then when we go to let's go now. I'm clipped on. Go to the scope cam. And here you can see the signals. Hold on. Yeah, so, 1 second. Get a little bit more. The only thing that's a little annoying is you can't measure you can't demo the capacitance clipped in at the same time, because the capacitance of, and like I think that the pull down resistor, the 1 mega ohm or 10 mega ohm resistor in the probe for the oscilloscope kind of messes up. So if I touch it, like, you're not going to see any signal changing, but you can see the two signals being checked. So you do, this is one pin and the other pin, and it does 4 samples, and you can actually select how many samples you want to do, and then the library will take that count and divide it by the number. So it's, you get a much faster response rate if you only do 1 or 2 oversampling. And you can go up to 64 oversampling, but then it's a little sluggish. Nothing I have to do is maybe figure out if I'm clocking the peripheral quite right. There's no documentation about the peripheral clocking really, because you just use their code. But I think I can clock it maybe 4 times faster. So let's go to the computer and I can show it. Okay, so this is the
You gonna be here for a bit?
No, I'm going to wrap up soon.
Tell me when I have 5 minutes.
Okay, I'll tell you when you have 5 minutes. Not yet. Okay, so
Look, I'm wearing a metal skull over here.
I know it's very hot. I'm
Yeah.
comfortable. So as I touch the pads, you can see the signals changing. Hold on. So normally it's around like 200 or maybe 300 is the measurement. And then let's see if I touch a pad, and then I'll stop the auto scroll. And you can see here, when you touch it, it goes up to 1,000 counts. So it's really easy to detect when you're touching it, because when you're not touching it, the count is about 300, or 200 even. And then when you do touch it, it's 1,000. And this is also telling me how long it takes for me to do the measurement. Again, it's completely related to how many oversamplings you do. The more oversamples, the more stable your measurement is, but you get like a trade-off with how fast the response rate is. So I can show just a demo of, like, let's make the filter level like 64. I'll show you. It's significantly slower. Although I think, again, I can speed it up a little bit. I just got it working, so I'm like, okay, now it's working. I got to get port B working and stuff like that. Okay. All right. So now you can see, yeah, it's like, it's not flying by. When you touch it, it takes a while, but the measurements are more, like, they're not as high. Like when I touch, it's only 500 because it's taking an average over many, many measurements. So I guess it's like, it just doesn't have as spiky a response. So here, I'm touching 2 pads at the same time. I get about 500. And then when I don't touch them, here I'm touching these pads to test them. I don't touch them, I get about 200, but it's taking a whole 120 milliseconds to test. So I'm probably going to go with about 4 times oversampling. And again, I want to maybe clock the peripheral a little faster. All right, so that's the update with capacitive touch. Any questions about the capacitive touch? Okay, great. And then the next update that I did, let's go to the overhead. So I did the capacitive touch. So that's freed up a bit of space. And so I actually moved these 2 buttons up. And then what I did is I kind of also had a couple of videos a couple weeks ago about this. I changed out the transistor. I had a plain transistor driver, just like, on-off pulse transistor driver for the speaker. And I've changed that now to be a little tiny Class D amp. It's a 1-channel Class D. It's the PAM 8301. Really adorable little SOT 23.6 pin. Just like power, ground, input, output. What are the other two pins? Oh, reference. Maybe there's like a differential reference. Oh no, sorry. It's bridge side low. So 2 outputs, and then I think like 1 gain pin or something. Anyway, so now I've made the speaker much larger. If you compare this to the speaker I had here, this is a 5mm speaker, and then I have the 1 transistor. This is Rev D. And this was very good for just tones. It could be like beep, 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 beep. Good for just playing simple musical tones. What's nice about this speaker is when you get to this size, actually the quality becomes significantly better. It's also much louder, so you can actually do sounds, like sound effects, and like the Taki library. So I thought I would load up one of those demos too. How do you think about that, Phil? Everyone's into it.
15 Helens agree.
Thank you, Helen. All right, so I'm going to upload one of our DAC tests. Oh, yeah, and then the speaker is driven through the DAC pin. So this is a demo where we just have like a ton of hex code. It's just a WAV file that's basically binaryized and 8 kilohertz sample rate. And then I'm just piping that into the DAC. Very simple. And then so it's playing this little tune. Hold on, let me get the...
Cool.
So it's kind of nice. And then I also have the Taki Demo, which is the Tom's Diner example. This is part of the Taki library, which is a phoneme-based like speaker driver. It's kind of cool because it doesn't take almost any space, but you can actually have it play words and sing. So what's nice about this library is you can have it speak words or like speak out something. So you don't have a display, but maybe you could speak the temperature or tell you like, if you're playing a game whether
Tell you how to set it up.
you want to lose, or it can tell you how to set it up. So that's kind of neat. And of course, you have the 2 megabyte of flash on there, so you can have WAV files and it can play them. Is it like awesome quality? No, but it's like good enough basically to have some basic audio output. I think it's pretty cool, and I think it's a worthy upgrade. It's a little bit more expensive. The speaker is about the same price. The DAC is like 15 cents more, but I think it's pretty neat. I like to have a really good audio sound effects capability. And then the last update, and then can you go to the overhead again? I'll show the last update, and then we're pretty much done. So last update is I pushed the buttons out a little bit, and then I had just a teeny little bit of space. So here's an IR transmitter LED, and here's an IR receiving LED, and then over here's an IR receiver. To make this all surface mount, you actually have separate IR receiver LED. It's a photodiode, and then here's this little amplifier chip that does like the biasing and amplification of the sensing element. And then we'll pipe that data as like a normal IR. It filters out that 38 kilohertz carrier wave and just gives you that raw modulated signal. So this will allow you to do like IR transmit and receive, as well as basic proximity sensing. Like you can tell if you waved your hand over it because you'll be able to bounce the signal off. Kind of wish it wasn't so close to the buttons because I think it's a little bit in the way, but I couldn't find a better place for them. So the next step, I want to get capacitive touch working on all the pads. And then we have to make a decision because Phil and I, what I really wanted to do is have the ability maybe to connect the DAC. There's only one DAC. So having the ability to connect one of the DAC pin to a headphone jack so you could plug into a stereo for like really good quality audio. But you can't do capacitive touch on the pin and drive a speaker at the same time. So the question is, do we give up a capacitive touch pin and just only have 7 cap touch and just say, hey, it's one pin isn't capacitive touch capable? Do we have this pad come out a different way somehow. Maybe, give up one of these ground pins. I don't know exactly yet what we want to do. Maybe I could switch out this 3.3 volt pin for A0. Could be kind of interesting, maybe. So that's what I got so far. I got the silk screen over, and then of course I still have to get that PDM microphone working. So.
Yeah, someone had a question. Is there a microphone? The answer is yes.
Yeah, there's a microphone here. This section actually used to be all the analog amplification section for an analog microphone, but then on the previous stream we got the PDM microphone basically working. I didn't get it filtered working, but I got definitely signal coming out of it. And what's nice about the PDM mic is it's digital. It's fully digital. So you use the I2S capabilities of the chip. You don't need an audio amplification circuit, so you save a ton of space. And then that's where I got that extra space to put in the IR receiver chip, this little guy here.
The chat says give up one touch pen.
Well, I could also give up a power pin, right? But then it's not backward compatible anymore, but maybe that's okay. I don't know. I mean, we'll have to discuss it. Not easy.
The pin you give is the love you gain.
Thank you for that insight. So that's the update. So we still have to make the decision. The biggest decision left is the speaker. Should I expose it? And if I do, how do we do that?
Someone said give up the ground pin.
Ground pins are really handy, though.
I know.
Well, we have
One is plenty.
We have 1, 2, 3 ground pins, which I like. 2 power pins, and then 1 VBAT pin, which is really nice for powering like NeoPixels.
Oh.
So it's tough. It's like, what do I give up? I kind of like having all the pins be capacitive touch capable. But yeah, it's like the one thing that I tried. I was like, well, now that I got capacitive touch working, can I get capacitive touch working with pin A0? Maybe I could
Someone
also.
says double use pin with a jumper.
Yeah, but nobody's gonna solder a jumper. It has
Yeah.
to be completely solder free.
Yeah.
Another thing I was thinking of is maybe having some sort of pad that you can clip onto somehow,
Yeah.
even though it's not maybe exposed easily. But I don't know how to do that or what to do.
These are all good ideas. Thank you, everyone, because, by the way, this is actually how hardware works.
Yeah.
And we show you the entire process because we're like that.
Yeah.
If you want to support Adafruit, go to adafruit.com, buy something. We are a completely independent site, pretty obviously, at this point. We're here for you and no one else. So anyone who's watching, you're the most important people to us.
Yay.
All right, that's it, Lady Ada?
That's all I got. That's my update.
Okay.
I'll release the free touch library once I fix the pin muxing thing so it doesn't completely destroy your microcontroller like I did.
Yeah, I know.
Right now, totally hard faulted. It's awesome.
Okay. All right, that's
Bye,
it.
everybody.
We'll do some shows later.
Good night.
I told you I would eat you. I told you. Say goodbye, Lady Ada.
Goodbye, Lady Ada.